Hello out there, and welcome to our Harbor Wild Watch lesson this week. We are rocking and rolling with the edible rock cycle today. So we will get started as folks start tuning in. And if you're tuning in later, as always, we like to know where you're tuning in from and what age or what grade the students joining you are in. I see Octavia is joining from Hardin, Montana. Thanks, Octavia, for tuning in here. Some things you'll need are Starbursts or some other taffy-like candy. We're going to be demonstrating the rock cycle using this delicious treat, and yes, you can eat it at the end. So we'll kind of go over the rock cycle, do our candy demonstration, and then conclude. So while we're kind of going over the rock cycle, if you want to do some prep, I've taken some Starburst and just chopped it up into some chunks to represent our sedimentary rock later. So yes, Rachel's definitely mentioning real rocks would be hard on teeth, so please don't eat your real rocks out there. That would be a sad day. Maybe a good day for a dentist. Alright, so the rock cycle is a pretty sweet deal. There are 3 different types of rocks. There's igneous, metamorphic, and sedimentary rock. And I hope you're ready for some dance moves because I have a little motion for each one. So you're welcome to shake it out, get ready, because we're gonna cover each type of rock and then demonstrate it using candy. So the first one we'll talk about is igneous rock. It comes from volcanoes. So for igneous, I want you to put your fists together and imagine erupting. Make some sound effects, do whatever. So igneous rock, say that as you erupt your volcano, is again rock that comes from volcanoes. So magma is underneath the Earth's crust. That's the melted rock that when it comes out of the crust is lava, and then when it cools, you get igneous rock. And that can be things like granite. Granite is igneous rock, or lava that has cooled very slowly, and all the minerals in that rock kind of you can actually see with the naked eye, the quartz and the feldspar and the mica that make up that granite. On the other hand, if it's lava that cools really quick, you'll have things like obsidian, where those minerals don't have time to crystallize their own little shapes, and so you get that really glassy, cool texture. So igneous rock, volcanoes. Ready for your next move? Shake it out. We're gonna stack it. And this is for our sedimentary rock. Sedimentary rock can be bits of dust, clay, sand, even tiny shell debris. So all those little bits of sediment will form layers, and those layers can undergo a chemical reaction, which forms sedimentary rock. So just like the material that it's made of, sediments, which again can come from any of these 3 types of rock, as well as living organisms, those sediments can form sedimentary rock. So stack it up and say sedimentary. Our 3rd type of rock is metamorphic rock. Now this one, you're going to need some heat. You're going to need some pressure. And when you put that together, we're going to change our rock. And so again, for metamorphic rock, this can be any of the 3 types of rock. So let's say some limestone that came from tiny little coral sediments formed into rock, and then that limestone undergoes heat and pressure. That can then become marble, which is a type of metamorphic rock. So it's kind of a cool way to change either type of rock, and even some metamorphic rocks can be further metamorphized. But yeah, thinking of that word metamorphic, think of butterflies or caterpillars going into a cocoon and doing a transformation into a butterfly. So heat and pressure are going to change that metamorphic rock. So do a little wave and say metamorphic with me. Metamorphic. Excellent. Okay, so these 3 different types of rocks can all get broken into tiny sediments, those nice green arrows here, through a process called weathering and erosion. And I think looks like we have Rachel on as tech. For Melinda, if you just go to our Facebook page, the live stream should be there. So we'll also post it at the end. So hopefully you can find us while we're out there. But yeah, if you check the main Facebook page to get on the live stream, you should be good. Although you're not on the live stream, so my message isn't getting out to you, but hopefully Rachel can see that. All right. Okay, so weathering and erosion are the two processes that will kind of break down and move these three different types of rocks that we have listed out here today. So weathering is that process of kind of loosening rocks up, and there can be all sorts of different types of weathering, from physical weathering, whether it's, you know, stepping on things, the pressure, I guess that's kind of biological almost because we're the ones moving it, but physical weathering could be something like water, filling in the crack of a rock and then freezing, and that expansion of the ice can actually break the rock apart. There's different plants, so imagine walking along the street, and you can see the grass growing through the cracks of the pavement and even causing that concrete to crack further. So that's a way that weathering can happen, again loosening up those rocks so that they can then move through the process of erosion. And then there's even things like lichens can cause an acid to build, and that acid can dissolve rocks. There's also things like acid rain, so this chemical weathering is a way that rocks kind of get loosened up. And then erosion is when dirt moves. So those tiny bits of rocks can get moved by either wind, water, or ice, so glacial erosion. And we did a fun lesson demonstrating glacial erosion, so if you want to check out our glacier lesson from a couple weeks ago, you can feel the power of that ice moving rocks using clay and sand. So that might be a fun one to look at after this lesson. So with that, all of this weathering and erosion can break down these three different types of rocks into sediments, which we're going to represent as our chopped up starburst. And again, because rocks are made of minerals, I can see in this starburst, each different flavor can represent the different minerals that might be the ingredients that make up the rocks that we see. So we've got some nice lemon and orange and strawberry and cherry. That, of course, would be things like mica and quartz and feldspar. In real life, that's definitely, I think we're about to make some granite here, but go ahead and take some of those sediments, and I realized, I don't know if I got old starbursts or what, but mine were really hard to cut, so hopefully you have an easier time molding your sediment starburst over there. But with the heat of my hand, I notice I can just kind of squish that together. Again, this is as if the sediments are forming layers, and those layers are starting to undergo a chemical reaction that really kind of sticks them together. So this would be an example of all one mineral forming a layer. I might add... Sorry, my starbursts are so hard. I'm going to add a second layer. If you're ever trying to identify rocks out there, you can look for the layers. If you find a rock with layers, that's a pretty good clue that you have a sedimentary rock. So we're starting to get pretty nice looking sedimentary rock here. Excellent. So I'm just going to squish that together a little bit more, and then we'll imagine our next adventure here. So our sedimentary rock, we're going to take this sedimentary rock and we're going to make it a metamorphic rock. And you can guess that indeed we're going to add some heat and pressure. So more than just kind of squishing it together, we're really going to start bending and mashing and maybe adding some twists. This would be occurring along our tectonic plates in some cases, where the rocks in the lower levels of our crust have shifted into place, and they're starting to really get just with the pressure of those tectonic plates that are moving, are going to get crushed and moved. And as you get closer to the Earth's core, it gets hot. And that heat and that pressure can start changing those mineral components. And we can start getting maybe a nice limestone turning into marble situation, or any other example of that metamorphic rock. So we're starting to see that those layers are getting a little bit more blurred. My fingers are definitely getting a good workout. I'm ready to eat this thing. But not until we make this metamorphic rock into igneous rock. And to do that, we're going to imagine that this has gone down close to maybe a fault line. It is melting into magma underneath our Earth's crust, and that we're going to demonstrate by sticking it in the microwave, because my little friction hands can't get it quite hot enough. And in case you needed proof that I am a total nerd, I wanted to show off the plate that I'm going to microwave our metamorphic rock on. This could also easily be sedimentary rock getting melted, if we wanted to do that. But this plate is Washington State's here. This is the Juan de Fuca plate that is slowly moving underneath the North American plate, and that friction is definitely probably creating some metamorphic rock, which is then melting into magma, which, if you look along the west coast of the United States, there are volcanoes like Mount Rainier, Mount St. Helens. Any of those big mountains along the coast here are all a result of the tectonic movement of the Juan de Fuca plate sliding underneath the North American plate, or maybe a better word for that would be subducting. There's another lesson we've done on volcanoes if you want to check that out later. But I'm going to stick this in the microwave for a couple seconds, and we're going to see what happens to our lovely metamorphic rock here. Alright, I'm going to watch while that microwaves for a little bit. Not too long, because I want to be able to still manipulate it. Okay. Couple seconds in, and my goodness, it's looking melty. Be really careful as you go to touch it, because just that couple of seconds made this pretty hot. You can see it's actually kind of bubbling a little bit. And those colors are definitely running together. If I were to take this igneous rock and maybe add more heat and pressure, carefully. Okay, it's kind of too hot to touch. We can see that again, the minerals of our starburst here are changing. If I mix that together more, I'm starting to get maybe one type of rock. If I mix over here, we're gonna get another type of rock. Stena's gonna melt off her fingertips. And again, you can see this nice gooey starburst mess is definitely starting to show an example of what could be that igneous rock if we were to melt our rock types into magma and then it were to cool. So with that, I'm going to let that cool off. Eat some sediments. Delicious. I love when science is tasty. It's a good time. But that is a simple, pretty easy demonstration of how minerals can form rocks, and those rocks can form sediments, and those sediments can form sedimentary rock. Those can transform into metamorphic rock, can get melted into igneous rock when that magma cools. And that, my friends, is the delicious cycle of the rocks. So I hope you enjoyed today's short and sweet video. This is our last kind of STEM lesson for a little while. We know that school's out and we're excited to hit the beach and share all sorts of fun beach content with you over the summer. So don't worry, we'll still be posting educational content online. So you're welcome to subscribe to our YouTube page, follow us on Facebook and Instagram. We'll be spreading the learn, have fun love out there in all of those ways. You can make a donation if you enjoyed today's video, and you can do that through the link on this video or check out our website. You can even become a steward club if you really feel so inclined to support Harbor Wild Watch, and that will put you kind of on the docket to be a volunteer, which of course volunteering right now is kind of a weird time because we don't really have any programs, but I'll be doing some trainings later in July about interpretation. So if you want to learn how to talk about cool animals that you find on the beach and get ready for when we can do public programs, you're more than welcome to join the Steward Club. Sign up to volunteer. I'll get you squared away for that. And of course, as a Steward Club member, we really appreciate those folks out there who are supporting Harbor Wild Watch, and we'll be sending you more fun, exclusive content your way. And then finally, share these videos. If you know somebody out there who you think might enjoy this content, send it their way. And if you had fun doing this lesson today, feel free to send some pictures of your starburst sedimentary rocks and metamorphic rocks, or maybe a video of you doing the igneous rock dance. We love that interaction too. So thanks so much for tuning in, and as always, we hope that you learned and had fun.